So in the second half of this section 8.1, I'm going to talk about type 1 and type 2 errors. And it's not something that I test heavily on, but it's an idea that students take some time to understand, and so we're doing a lot of it. And even if you don't understand it after this video, you might want to watch it in a week after that, whenever you watch it. And as we do some practice, you may understand better. So we're going to look at a court case where we have the null, which is, how it is that the defendant is innocent, and the alternative is that the defendant is guilty. So obviously this is essentially what happens in a court case, innocent until proven guilty. And we want to know, is the evidence strong enough to say that the defendant's not innocent. So there's 4 situations that can occur here, where 2 of them are the correct decision and 2 of them are the incorrect decision. So let's think about, say, the first one here. If we fail to reject the null, so that means we do not reject that the defendant is innocent. Okay? If that is actually true, we're going to conclude, given a court case, that the person is not guilty, when in fact they are not guilty. That is what we would call the correct decision. Okay? Because it is true that the defendant is innocent, and we do our test and we fail to reject H naught. So remember, fail to reject means we do not reject H naught. And so our test shows that we do not have sufficient evidence to support the alternative. So we are going with H naught, and that's the correct decision. Now, if we fail to reject H naught, we are still going to conclude not guilty. But there is the possibility that this H naught is not actually true, that the defendant is in fact guilty, and that is an error. So it's an error to conclude that the person is not guilty when in fact they are guilty, and of course this happens all the time. This is what's called a type 2 error, and I'll define it on a different slide. Okay. Now, another thing that could happen is if you reject H naught, in this case, you're rejecting that the defendant is innocent, you are concluding that the defendant is guilty. But there's 2 situations. If H naught is true, if the defendant is actually innocent, then you concluded guilty when the defendant was actually not guilty. And that's what's called a type 1 error. And it's all related to H naught and H1. If, in fact, the defendant is not innocent and you conclude guilty, then you've concluded guilty when the defendant was guilty. And that is a correct decision as well. So the idea there, and to understand, is, this happens in real life, where we look at evidence, thinking about a court case, and we have to determine whether we believe, that somebody is guilty or not guilty. And sometimes we are wrong, and sometimes we are right. And that's the same with hypothesis testing. Now, typically, as long as we take a random sample and, do good work, overall, we're hopefully going to be correct. But the point is just that errors can be made. So, big thing to note, the defendant is never declared innocent. And, that's how it is even in the real world, that's not what happens. And that's really the same with the hypothesis testing. We're going to support something. We're going to say we can support the alternative that something has changed, but we're not telling you for sure that's what happened. We're just saying that the evidence supports it. And that's the whole point of statistics, is never knowing anything for sure. So here's just the definitions of the type 1 and type 2 errors. So the type 1 error, and you can look back up on the example, it's rejecting the null hypothesis when the null hypothesis is actually true. So you reject it, but it was actually true. So the idea here is H naught true, but you reject H naught. So if H naught is true, you shouldn't be rejecting it because it's true. The type 2 error is when you H naught is actually false, but fail to reject H naught. Failing to reject the null, but the null is actually false. So notice all of these errors are based on the null. None of them are based on the alternative, because your null is the statement of no change. It's what you're trying to say is something actually different than this. Okay, so that's the idea here. Now, alpha is used to represent the probability of such an error, and alpha is actually going to be really important in our hypothesis testing. Beta is not important in our hypothesis testing, but I want you to see that depending on what alpha is, beta has a relationship with alpha. So our focus will be on our alpha. It's going to be called our significance level, but that'll come soon. Okay, on average, it used to take 30 minutes to find parking, but we think we have sufficient evidence to say that our time has decreased. But in fact, the true parking time is still 30 minutes. What kind of error did we make? Is it type 1 or is it type 2? So think about this. The H naught here is that the mean time it took to find parking, that's a really long time, is this. And then the alternative was that you think you have sufficient evidence to show that the time has decreased. So what you decided was, because sufficient evidence, you decided to reject your H naught. You rejected this. However, the true parking time is still 30 minutes. So H naught is actually true. So notice that is H naught is true, but you rejected it. So you're making the type 1 error. And did I write anything else? No, that's everything we need. All right, last page of 8.1. More of this, more of this. Okay, just to really hammer it home. The majority, this is just a note. This is good because sometimes we see this on problems. When we use the word majority, or when I say we, I mean like the book or like statistics, the majority is a number or percentage equaling more than 50% of a total. To test the claim about a majority, your null hypothesis, and this is always proportion because it's a percentage, 0.50. Okay, so sometimes you'll see that, and for students, they're like, I don't have a number, like what am I supposed to use? So a Gallup survey, so Gallup, very important survey company, reports that 57% of 504 randomly selected gun owners support stricter gun laws. Test the claim that a majority of gun owners favor stricter gun laws. Write out the hypotheses for this example. So understand, we have H naught, H1. I'm always going to write these. Always write them. You're doing your homework. Please write them. This is our sample data here. So this should not be part of our null or our alternative, because that's what we're trying to show to see if the null has changed. So when they use the idea of majority, they're saying, okay, let's say that it's 50%. And then you can see we have this sample data that shows 57%. So is in fact the proportion greater than 0.50? So notice both of them have proportion, both of them have 0.50, and all that sample data is going to do is we're going to use it to test to see whether we think that it's greater than 50%, which would be the majority. Now, a type 2 error in this example would be to mistakenly, okay, so maybe I'll go back really quick here. The type 2 error is mistakenly failing to reject the null hypothesis when it is actually false. H naught is false, but we fail to reject H naught, okay? So we mistakenly fail to reject, and I'm going to put it in the context of the problem, mistakenly fail to reject H naught, and then I look and see what H naught is. mistakenly fail to reject that the proportion of gun owners, it's a sentence, gun owners who favor stricter gun laws is 0.50 when in fact, and then I'll go back, when it is actually false. For type 2, when it's actually false. So I come back here, when in fact it isn't 0.50. Now, I don't say it's greater than or it's less than or whatever. It's just, it's not actually, we did not reject the idea that P is equal to 0.50, but the type 2 error that could be made would be that that is actually false. So it isn't 0.50. Okay, that's all I need for that. Okay, I promise we are almost done. All right. Your company markets a computerized device to test a patient's mean resting heart rate. Based on the sample results, the device determines whether there is significant evidence that the patient's mean resting heart rate is greater than 100 beats per minute. If so, your company recommends that the person seek medical attention. Okay, so sometimes type 1 and type 2 errors are more or less dangerous. Okay, so in this case, mean resting heart rate, we have that it would be 100, that would be the statement of no change. And then there's some sample evidence to say greater than 100 beats per minute. So we can write that. So we want to look at which error is worse for the company. So let's say you have someone and you're testing their mean resting heart rate. Maybe you do that multiple times. You take a random sample. If in fact their mean resting heart rate is actually 100 beats per minute, and you don't reject the fact that their mean heart rate is 100 beats per minute, then you've made the correct decision, okay, that's correct. Now, if H naught is false, if in fact their mean heart rate is not 100, and you reject that it is 100, well, that's also the correct decision. However, this is where the errors come in. So let's say that H naught is false. Let's say that in fact the mean heart rate of this person is not 100 beats per minute, but yet you fail to reject that. You say, the device says, oh yeah, no, it is actually 100, but it's not. Is the person going to seek medical attention? They're not, because the thing told them that it was 100. So they didn't, but they needed it, okay? Now the type 1 error is that H naught is true, okay? So the mean heart rate is 100. And in fact, we rejected it and said, no, it's greater than 100. The device says, oh, it's greater than 100. So that person's like, oh, I got to go seek some medical attention, but they didn't need it. So when we look at this, you can see that in this case, which one is worse? Which one would be worse? Okay, so you're probably thinking this one is worse because they didn't seek medical attention and they needed it. So in this case, a type 2 error would actually be worse because that person may end up suing or something and saying, I needed help and this thing told me I was fine and you're going down. Okay, so sometimes one of the errors is more more important or more, I don't really want the word debilitating, but, more ramifications for having that kind of error. So we will not know 100% if our conclusion of our hypothesis test is correct. We'll never know. It's all based on sample data. But the whole thing here is that we're going to assign probabilities to making the type 1 and type 2 errors when we complete a hypothesis test. So depending on which one is more, scary, we can choose that alpha that we're going to use, which we'll use in 8.2. Okay, so level of significance is the probability of making a type 1 error. we take a sample. If we take a sample, that makes H1 look wrong when it's actually true. So that's the type 1 error. That's just another way to say it. So, but that's what the level of significance is, the probability of making a type 1 error. So what happens is, as you increase the probability of one of the types of errors, the probability of the other type decreases. So I really should just say, as you increase the probability of one type, the probability of the other type decreases. Okay, so in choosing a significance level, often we will be given the significance level, but you could arguably be asked to choose it based on which error would be more scary. So the significance level alpha is typically going to be between 0.01 and less than 0.10. And we'll talk about, using this in 8.2. But this is what the probability of making a type 1 error would be. Between basically 1% and 10%. Nobody really wants to go higher than that because they're like, that's like a really high probability of error. So when a type 1 error is, say, for example, 0.01, that means the type 1 error is serious. Okay? It would be very serious to make a type 1 error. You do not want to do it. So you have a very low alpha. Type 2, not serious. Okay? Not so serious. Now, in the middle, typically, and you might see 0.02, and you could see maybe, 0.07. I mean, it's not common. These are the three most common, but this would be a case where it doesn't really matter. And there's some hypothesis tests where you're like, it doesn't really matter if I make either error, like nobody's gonna be seriously injured or something like that. So if you choose 0.05, you're saying either a type 1, type 2 error, not a big deal. And then the last one here would be that the type 1 error is not so serious, but a type 2 error is serious, okay? And again, typically we'll be given our alphas, but the idea there is just, as you can see, one of them being serious will relate to another one maybe not being as serious. And sometimes they kind of have the same level of seriousness. And so then the 0.05 is a middle ground there to just kind of cover your bases and say, okay, well, hopefully I don't have an error, but if I do, it's kind of equal on either side. And that is section 8.1.